you're a sky, 'cause you're a sky full of stars.
The plane was shaking violently at 30,000 feet. Alarms screaming through the cabin. Pilots frantically searching their instruments for answers they could not find. When a quiet passenger in seat 23C noticed something everyone else had missed, a tiny detail that would save 217 lives before the aircraft plunged into the Atlantic Ocean. This is the true story of how an ordinary person became an unexpected hero in the sky. Before we dive in, what time are you listening? Where are you from? Drop a comment below and tell me. Marcus Chen fastened his seatbelt as Flight 742 prepared for takeoff from Boston Logan International Airport. The mechanical engineer had made this journey dozens of times, flying to London for business meetings that blurred together in his memory. He carried his laptop bag, a thermos of coffee, and the same tired expression worn by every frequent traveler who had long ago stopped finding magic in air travel. The Boeing 767 was one of the older models in the fleet, but Marcus trusted these machines. He had spent 15 years designing components for aircraft manufacturers. He knew every rivet, every hydraulic line, every backup system that kept passengers safe at cruising altitude. The flight attendants demonstrated safety procedures while most passengers scrolled through their phones during the final moments before departure. Marcus glanced out his window at the ground crew performing their checks, watching the baggage handlers load the final containers into the cargo hold. Everything appeared routine. The engines hummed to life with that familiar rising whine. The aircraft rolled backward from the gate, turned toward the taxiway, and joined the queue of departing flights. Marcus opened a technical manual on his tablet, planning to review specifications for a project due the following week. The plane accelerated down the runway, wheels lifted off the tarmac, and Boston dropped away beneath them as they climbed into the grey November sky. 3 hours into the flight, Marcus was half asleep when the first jolt hit. The aircraft dropped suddenly, as if an invisible hand had shoved it downward. Passengers gasped. Drinks spilled. The seatbelt sign illuminated with a sharp chime. A flight attendant stumbled in the aisle, catching herself on a seat back. Over the intercom, the captain's voice came through with forced calmness, asking everyone to return to their seats and fasten their seatbelts due to unexpected turbulence. Marcus sat up straighter, his engineer's instincts alert. This did not feel like turbulence. Turbulence had a certain rhythm, a pattern of rises and falls. This felt different, wrong somehow. The plane shuddered again, harder this time. The woman beside Marcus gripped her armrest, knuckles white. A child started crying several rows back. Marcus pressed his face to the window, looking out at the wing. The flaps appeared normal. The engine nacelle showed no visible damage, but something in the way the aircraft was moving troubled him. There was a slight asymmetry to the vibrations, as if one side of the plane was experiencing more stress than the other. He had felt this once before, years ago, during a test flight of a prototype. That aircraft had been grounded for 3 weeks, while engineers traced the problem to a faulty sensor that was feeding incorrect data to the flight computer. Another violent shake rattled the cabin. Oxygen masks dropped from the overhead compartments with a series of clicks and thuds. Passengers screamed. The masks dangled and swayed as the plane tilted at an angle that felt too steep. Marcus pulled his mask on, but his mind was racing through possibilities. He unbuckled his seatbelt despite the illuminated sign. despite the flight attendant's shouted instructions to remain seated. He moved to the emergency exit row where he could get a better view of the wing and engine. What he saw made his blood run cold. The wing was flexing more than it should, bending in a way that suggested the hydraulic systems were not responding correctly to the flight computer's commands. He knew he needed to get to the cockpit, but how could a passenger convince the crew to listen during an emergency? Airport security protocols meant the cockpit doors remained locked and reinforced. But Marcus also knew that pilots flying a crippled aircraft might be desperate enough to accept help from any source. He pushed his way forward, grabbing seat backs for balance as the plane continued its erratic movements. A flight attendant blocked his path, telling him to return to his seat immediately. Marcus spoke quickly, identifying himself as an aerospace engineer, explaining that he might know what was happening to the aircraft. The attendant looked skeptical, but also terrified. She spoke into her handset, relaying Marcus's message to the cockpit. 30 seconds passed. 45. The plane dropped again, and this time Marcus heard something snap, a sound that made his stomach clench. Metal fatigue, a structural component. Giving way under stress, they were running out of time. The cockpit door opened a crack, and the flight attendant gestured for Marcus to approach. He squeezed through into the cramped cockpit where two pilots were wrestling with controls that seemed to have minds of their own. The captain glanced back at him, sweat beading on his forehead, and shouted over the alarms, asking what Marcus thought he could do. Marcus leaned between the seats, studying the instrument panel. Every gauge and display showed conflicting information. Altitude readings that made no sense. Airspeed indicators disagreeing with each other. The flight computer was getting bad data, and the pilots could not manually override the automated systems, because they did not know which readings to trust. Marcus asked if they had experienced any maintenance issues before takeoff. Any unusual readings during the pre-flight check? The co-pilot shook his head, saying everything had been normal. But Marcus was studying the hydraulic pressure gauges, watching how the needles fluctuated. He had seen this pattern before in simulation. A pressure transducer, a small sensor that measured hydraulic fluid pressure, could fail in a way that sent false readings to the computer. The flight computer would then adjust the control surfaces based on bad information, creating the exact kind of erratic behavior they were experiencing. The problem was that there were dozens of these sensors throughout the aircraft, and finding the faulty one would normally require hours in a hangar with diagnostic equipment. But Marcus had an advantage. He knew these systems intimately, had helped design the redundancy protocols. He asked the captain to try something specific, to manually reduce power to the number 2 hydraulic system while maintaining full power to systems 1 and 3. The captain hesitated, explaining that standard procedure during a hydraulic emergency was to keep all systems online for redundancy. Marcus insisted, saying that if his theory was correct, one of the sensors in System 2 was sending corrupted data, and the only way to isolate it was to take that entire system offline. The pilots exchanged glances. They were losing altitude. The aircraft was becoming harder to control, and they were over the middle of the Atlantic with nowhere to land. The captain made his decision and reached for the hydraulic system controls. The moment System 2 went offline, the change was dramatic. The plane stopped its violent shaking. The wings leveled out. The nose came up to the correct pitch angle. In the cabin behind them, passengers were crying with relief as the aircraft steadied. but Marcus knew they were not out of danger yet. Flying on 2 hydraulic systems instead of 3 meant reduced redundancy and less margin for error. They needed to maintain this configuration all the way to London, another 2 hours of flight time, and hope that the remaining systems held. The captain was already on the radio, declaring an emergency and requesting priority landing at Heathrow. Air traffic control responded immediately, clearing all other traffic from their approach path. Marcus stayed in the cockpit, monitoring the gauges, watching for any sign that another sensor might be failing. The pilots flew with intense concentration, hand-flying the aircraft rather than trusting the autopilot. Every minor adjustment of the controls had to be precise, calculated. The co-pilot was constantly checking and rechecking their fuel levels, their descent rate, their position relative to the airport. They crossed over Ireland, began their descent over Wales, and finally saw the lights of London appearing through the clouds. Emergency vehicles were already assembled on the runway, fire trucks and ambulances positioned at intervals, their lights flashing in the darkness. The landing was smooth, almost gentle, a testament to the pilot's skill. The aircraft touched down, reversed thrust, and rolled to a stop. Passengers burst into applause, some sobbing, others laughing with the giddy relief of people who had just survived something terrible. Marcus made his way back to his seat on shaking legs, the adrenaline finally catching up with him. The flight attendants were already preparing to evacuate, but the captain announced that it would be a normal deplaning, no emergency slides needed. As passengers filed off the aircraft, many stopped to thank the crew, unaware of the passenger. In seat 23, C would help save their lives. Marcus was the last to leave. The captain met him at the cockpit door, shaking his hand with a grip that conveyed more than words could. The airline investigators would later confirm Marcus's diagnosed. A pressure transducer in hydraulic system 2 had failed, sending random voltage spikes that the flight computer interpreted as wild pressure fluctuations, causing it to make dangerous corrections to the control surfaces. It was a rare failure mode, one that had only happened a handful of times in the entire history of commercial aviation, and it required someone with Marcus's specific knowledge to diagnose in real time. The incident made international news, though. Marcus declined most interview requests. He was not interested in being called a hero. He had simply done what his training and experience had prepared him to do, recognizing a problem and solving it. But for 217 passengers and crew members, Marcus Chen would always be the person who saw what others missed, who stayed calm when everyone else panicked, who stepped forward when the situation demanded action. The airline later discovered that several other aircraft in their fleet had the same transducer model installed, and they quietly replaced every single one during overnight maintenance sessions. Marcus returned to his normal life, back to his office and his design work, but something had changed. He began volunteering with aviation safety organizations, teaching other engineers about the importance of understanding not just how systems are supposed to work, but how they can fail in unexpected ways. He gave lectures at universities, showing students that engineering is not just about calculations and specifications. It is about being prepared for the moment when theory meets reality at 30,000 feet. Every system, no matter how well designed, can fail. Every redundancy, no matter how carefully planned, has limits. And sometimes the difference between disaster and survival comes down to one person who notices what everyone else overlooks. The story of Flight 742 reminds us that expertise matters, that knowledge can save lives, and that heroes are not always the people wearing uniforms or holding positions of authority. Sometimes they are quiet passengers in seat 23C, carrying technical manuals and thermoses of coffee, waiting for the moment when their unique combination of experience and insight becomes the most important thing in the world. Marcus never sought recognition for what he did that day. But every time he boards an aircraft now, he still glances at the wings, still listens to the engines, still pays attention to the small details that most passengers ignore, because he knows that safety is not automatic, that vigilance matters, and that sometimes one observant person can make all the difference between tragedy and survival. So, if you like this video, please like and subscribe for more videos like this.